Hi everyone. Okay, so today we will discuss about the pre-order traversal. In the previous video, what we have discussed about the searching technique in the binary tree. So we have understood about the what are the different searching techniques like DFS, depth first search, and the breadth first search. As part of the depth first search, we have seen that there are three different traversal techniques, algorithms are there. Also, these are pre-order, in-order, and the post-order traversals. Now, I have given example. Also, you have gone through the how we can figure out these three algorithms, how they are actually working. So today we will just talk about the pre-order traversal. In the previous, so if you haven't watched that video, please click on the I button. You will get the video link. And first of all, you can watch that video, then come to this one, so that you will understand the basics of the binary tree. Now, what is pre-order traversal? Pre-order traversal is one of the depth first search technique in a tree, in which you will traverse the tree in some particular order. What is the order? First of all, you will print the root node, then you will go towards left side, then you will go, once you are done with the left side, you will go towards right side. All right. Now, let me explain you with the help of one example. So here what we are doing, let's say we have one tree here. In the tree, what I will do, first of all, I will print the root node, which is nothing but simply 1. Then we will go towards left side. Here I will just print the root number 2. Then I will go towards left side, I will print the 4. So once we are now from 4, we cannot go towards left side because there is nothing. So you will come back to the parent node, and from 2, you will go towards right side where you can see node number 5 is present. So you will print 5. Now from 2, you will come to parent again, which is 1. From 1, we are done with the root, we are done with the left part. This complete part we are done. Now you will go towards right side. So again apply the same logic for this right subtree. So what we will get? We'll get 3, then 6, then 7. So pre-order traversal of this tree is nothing but 1, 2, 4, 5, 3, 6, and 7. All right. Now let me go and explain you how we can write the code for this one. Now there are two ways. Okay. One is the recursive pre-order traversal. Now, from the word recursive, you know that recursive means calling the same function again and again. All right. So let's say there is one function we will write for the pre-order traversal. We can give the name as the pre-order of root, which will take one input, which is root. Now, first of all, what we will do? You know, we will print the root node. Once we are done with the root node, we will go towards left side. And here what you will print, you will call the same function with the left subtree. So in this 3 lines of code, you can see, first of all, we'll print the root, then we will go towards left side. If we are done with the left side, we will go towards right side. So this is simply very simple logic, and I hope you will understand it. So let me explain you with the help of one okay, let me quickly explain you what I am trying to say here is. So first of all, you will print this one node, right? So you will have here 1. Now, what you will do after 1? After 1, you will call the same function with this node, right? Again, you will print the 2. All right. Now, what you will do? You will call the same function with the left subtree now, which is nothing but 4. So 4 is root, so you will print the 4 here. Right? Now, what you will do? From 4, you cannot go in left and right. So from 2, we can go towards right side. So this step will bring us to the 5. So you will print 5 now. Alright. So we got the 5. Now we are done with this complete tree and we are done with 1 already. You will apply the same logic for this right tree now, and what you will get, first of all you will get 3, then you will get 6, alright, then you will get 7. This is all done, right? So let me take you to Eclipse so that quickly we can understand. Now in the Eclipse, first of all, you need to understand how to represent a node in a tree. So this is the Java code. Here what you can say, there is one class node. Every node will have 3 things in it. One is the data, means what is the node value, and what is the left side of the tree, and what is the right side of the tree. So node and the left subtree and the right subtree. Alright. Now in the constructor of this node, I have initialized the data with the value which we are passing into the constructor. And we are assigning left and the right subtree as null. Right? Now here what I have done. How to construct a tree. This is very simple logic I have applied. So I have constructed the same tree, this one, and you can see root is 1, then left side of root is root number 2, node 2, you can see here, right side of root is node 3, and left of node 2 is 4, and right is 5. So this is the same tree, okay? So this is how you can construct a tree, and this is very easy way actually. Whenever you have, let's say, lot of nodes, let's say 100 nodes. So this way you cannot do. What you need to do is just create one method. And in that method, you need to pass the node, root, and the key which you want to insert. And that way you can do. But here I just made the things very simple for you. So this is the way you can start with, and you can easily construct a tree here. Now let me explain you the recursive preorder traversal. So here I have written one method called preorder, which will take the root as the input. Now, what is the first step I told you? First of all, you will print the root node. All right. So let me just print the root node here. And once we are done with the root, what we will do, we will call the same method for the left subtree. So we are done. Then once we are done with the left subtree, we will call the same method with the right subtree. All right, we are done. But did you see one thing? Whenever I talk about the recursive approach, you can check my previous videos. So most important thing is whenever you are writing the recursive solutions, you need to apply the base case. Otherwise, your function will never end. You will keep calling, keep calling. So here, when you will stop, tell me. You will stop once you reach to the node whose value, or once you reach the node which is null, right? So here I can say, if root is null, that means do not call, right? So this is our base case, and it will stop us from keep calling. It will stop us from the recursive call and all, from the infinite call and all, right? So whenever you are writing recursive solutions, always think about the base case and do not miss the base case. Otherwise, your function will never end. Let me just run it. We'll see the output. So you can see we got 1, 2, 4, 5, 3, 6, 7. So you can see 1, 2, 4, 5, 3, 6, 7. Got it? Very good. So now this is all about the recursive preorder traversal. I hope you understood it. If you have any doubt, anything which is not clear, please comment out. I will be happy to help you. Next, we will jump to the preorder iterative solution. How we can achieve the iterative, how we can write the iterative solution for the same. Okay, so what is the concept? First of all, you want to print the root, which is nothing but 1. All right. So first of all, let's say you will print the, here, let's say you will print the 1. So simply you can write here 1, let's say. All right. Now, once you are done with the 1, what you will do, you will go towards left side. So you will go from 1, you will come to the 2. All right. You will update the root with root dot left. So you will come here now. Now again you will print the 2 because 2 is the root, and again you will go towards left side of 2, which is nothing but 4. So you will print 4 again. Now once you are at 4, okay, you are not having the left child, you are not having the right child. Now from 4 you want to go towards 2. Okay, because now we are done with the 4. Now you want to go to the node number 2. So from 4 in the tree, we can come from top to bottom, right? Because we have left hand child, so we can come from top to bottom easily. But how to go from bottom to top? So how we can go to the node 2 from node 4? There is no link, nothing is there, right? So how to solve this problem? This is the only problem in this pre-ordered iterative way. So just think about it. From here, you want to go to the 2. From 2, you want to go to the 1. So don't you think if we can store these nodes in some order, and while coming from bottom to up, if we get the reverse order, it means we got our thing which we are looking for. So here, I will do one more extra thing here. Now, whenever you were going towards downside, okay, just keep storing the node into one stack. So first of all, you will store 1 into the stack. Well, now you will come to the second, again store the 2 into the stack. Okay. Now you will come to 4, again store the 4 into the stack. Right? So now from 4 you cannot go in the left side, you cannot go in the right side. So what you will do, you want the parent of 4. So if we reach to the point where our node become null, we will pop the element from the stack. So you will pop the 4 from the stack. Now, whatever element you have popped, just update your root with the popped element dot right. Okay, because root is already printed. So whatever element you are popping out from the stack will not print it. Okay, so just update the root with the popped element dot right. So right of 4 is also null. Again null. Now again our root become null. Again you need to pop the element from the stack. This time you are popping the element 2 from the stack. Okay. Now what is the right of 2? Right of 2 is nothing but 5. So we came to this point now. Again, we will apply the same logic. We will insert the 5 into the stack, and then we will print 5 here, and then we will go left side of 5. So again, we reach to the null. Okay, because left of 5 is null. Whenever you are reaching to the null, what you need to do, you need to pop the element from the stack and update the root with the popped element dot right. So right of 5 is again null. Again, you encountered null, just pop the element from the stack. Now you will pop the 1 from the stack, right? Now update the root with the right of the popped element, which is 1's right. So now you are at node number 3. Understood? Now again you will apply the same logic. Insert 3 into the stack and move towards left side of root. So you came to 6. Insert 6 into the stack, and what you will do now, you will go towards left side of 6. So your root became null now. Now whenever you will going this side, you will print 3 and 6 also, right? So you have printed 3 and 6 also. Now left of 6 is null. You will pop the element from the stack. You will update the root with the right of 6. So right of 6 is null again. Again pop the element from the stack. So root will be right of 3, which is nothing but 7. So you came to this node now. What you will do? Print the 7 and insert 7 into the stack. Right? Now you will go towards left side of 7. So your root became null. Pop the element from the stack. You will pop 7 from the stack, and you will go towards right side of 7, which is null. So if stack is also empty, root is also null, that means we are done. Right? And you can see we got this particular order, which is nothing but preorder traversal. So I hope you understood this logic. So very simple thing. We will take the root node. Okay, we will keep going towards left side. While going towards left side, we will keep printing the node. Along with, we will keep inserting the node into the stack. Okay, once we reach to the node null, okay, then you need to pop the element from the stack and update the root with the popped element dot right, and apply this logic for every node, and we are done. Let me explain your code. Okay, I hope it is clear. So let me jump to the coding part here. I have inserted the same tree here also. So I will simply jump to the coding part just to save our time. What I told you here. First of all, you will, let me just take one temporary node because I don't want to use the same root variable everywhere. Okay, so let's say my temp is root here. I will take one stack, right, just to store the node. So you will take one stack as the input, as the store the data. Now I need to import the library Java util. So we are good. Now what I told you, let me just apply one loop. I don't know when it will stop from the loop. Okay, as of now I don't know. So what is the first thing you will do? First thing you will do is if your temp is not null, right? So first of all, I told you we will print the node. So we will print the node and you will say temp dot data plus what you will do, you will just insert this temp into the stack also. Right? Why we are inserting? Because when we reach to the end, how to come back to the parent? So we use the stack here. So you will simply insert the temp into the stack and update the temp with the temp dot left. Right? We will keep doing this thing. Once you reach to the 4 dot left, it means your temp became null. Now, if your temp become null, you will not go inside this if, you will come in the else part. What I told you, if whenever your temp is null, you need to pop the element from the stack. So what you will do, if your stack is empty, it means we cannot pop. Temp is also null, stack is also empty, that means we are done. We have printed the complete tree. If stack is not empty, I will pop the element from the stack first of all. Now how to pop element? We have stack.pop method. And this way you got the top element. You will get the top element of the stack. Now we will not print this top because we have already printed this while inserting into the stack. So you need to go towards right side of this. So you just need to update temp equals to temp dot right. Okay, and we are good to go. So very simple logic. Our condition when will stop? If temp is null, stack is empty, we are done. Else we will keep doing the same. Let me run it. So you can see we got 1, 2, 4, 5, 3, 6, 7. 1, 2, 4, 5, 3, 6, 7. Understood? So just pause the video and think if anything is not clear, and if you feel something is not clear, please comment out. I will be more than happy to explain you guys. And in the next video, we will be covering about the inorder, and then we will be covering about the postorder traversal. Thank you so much, everyone. Enjoy.